multiplication of 1 1 1 with 1 minus 2 1. So you will get 1 into 1 1, then minus 2 plus 1. So again you will get 0, and similarly you can check that x3 into x1, that is also 0. So these 3 eigen vectors are not only just eigenvector corresponding to each corresponding to eigenvalues, but they are orthogonal. You can say they are orthogonal, right? So and then now we normalize that orthogonal matrix by its norm. So our first eigenvector is 1 0 1, right? So the norm of that eigenvector is root 2, because how we find norm? We know that u is equal to u1 u2 u3. So norm u is equal to norm u using Euclidean inner product, norm u is equal to under root u1 square plus u2 square plus u3 square. So that's why if our vector is minus 1 0 1, so what is the norm of that vector? Under root minus 1 square plus 0 square plus 1 square. So that will become root 2. So that's why we are dividing each eigenvector by its norm, and then we are putting in column, right? So our first eigenvector is minus 1 0 1, and the norm is root 2 for that eigenvector. So that's why we are dividing each eigenvector by its norm, minus 1 by root 2, 0, 1 by root 2. Then second eigenvector is 1 1 1, and similarly we can find the norm of that eigenvector, that is root 3, under root 1 square plus 1 square plus 1 square, that is under root 3. So that's why our second column is 1 by root 3, 1 by root 3, 1 by root 3, and similarly you can see the final eigenvector is 1 minus 2 1. And what is the norm of this eigenvector? Under root 1 plus 4 plus 1, that is under root 6. So that's why 1 by root 6 minus 2 by root 6, 1 by root 6. So m dash am, that is equal to 1 0 0 0 3 0. This is our diagonal matrix, in which all the diagonal entries are not just an eigenvalues, 1 3 3 0 0 0 0 0 0, right? Other elements are 0, and the main diagonal entries are 1 3 3, that is equal to D. Now take x is equal to my. So q is equal to x dash ax, that is equal to y dash m dash a my, that is equal to y dash, and this is m dash am. So we put the value of this. M dash means transpose of m. Okay, when you multiply these three matrices, you will get this diagonal matrix that you can check. And here this is our equation, q is equal to x dash ax, where x is equal to my. So x transpose, that is y dash m dash a my, that is equal to y dash, and this m dash am, put the value 1 0 0 0 3 0 0 0 3 y. So that is equal to, you will get y1 square plus 3y2 square plus 3y3 square as the required canonical form. Okay. Next question, question 6a. Find the matrix for the linear transformation L, which is going from P3 to M 2 cross 2. That means this is a set of polynomial of third degree to set of 2 cross 2 matrices, defined by, how we define that L is L of ax cube plus bx square plus cx plus d, that is equal to minus 3a minus 2c. The 2 cross 2 matrix, the first row is minus 3a minus 2c minus b plus 4d, 4b minus c plus 3d minus 6a minus b plus 2d. With respect to the standard basis b, x cube, x square, x1, and c is equal to 1 0 0 0 0 1 0 0. You can see this all 4 matrices are standard matrix for 2 cross 2 matrix. The first one is 1 0 0 0, then 0 1 0 0, then 0 0 1 0, and then 0 0 0 1. Okay. So what is our b? basis B, that is x cube, x square, x1, which is given, and this is our C, right? So first of all, find the value of L x cube, where L is our transformation. Put the value of L of x cube. Now L of x cube means A is 1, B, C and D are 0, correct? In this definition you can see L of x cube. You want to find L of x cube. So that means A is 1 and B, C, D are 0. So put A is equal to 1 and B, C, D are 0 in this 2 cross 2 matrix. So finally you will get minus 3, then minus 6. These two are 0, right? Because there is no A in this 2 other diagonal elements. So that's why you will get minus 3, 0, 0, 6. And if this 2 cross 2 matrix, if we can express as a linear combination of standard matrix of 2 cross 2, then we get minus 3, 1, 0, 0, 0, then plus 0, 0, 1, 0, 0, then plus 0, 0, 0, 1, 0, and then minus 6, 0, 0, 0, 1. So our first column is minus 3, 0, 0, 6 of the required matrix. Minus 3, 0, 0, 6. This is our first column. Similarly, we can find L of x cube, L of x square. So in that case, A, C and D are 0, B is 1. So put right hand side in this definition, A, C and D are 0 and B is 1. So you will get 0, minus 1, 4, 0, correct? 0, minus 1, 4. Okay, 0, minus 1, 4 and minus 1, because the, here is also B, right? So 0, minus 1, 4, minus 1. Okay, and when we express this matrix in terms of linear combination of standard matrix of 2 cross 2, finally you will get 0, minus 1, 4, minus 1. Similarly, we can find L of x, that is C is 1, A, B and D are 0. Put C is 1 and A, B and D are 0. You will get minus 2, this is 0, minus 1, okay, and this is 0. So minus 2, 0, minus 1, 0. And the third column of the required matrix is minus 2, 0, minus 1, 0. Similarly, we can find L of 1, that is D is 1, A, B, C 0. So put D is equal to 1 and A, B, C 0 in right hand side. So you will get 0, 4, 3, 2. 0, 4, 3, 2. Okay. So the last column of the required matrix is 0, 4, 3, 2. Put all these vectors in the column. First column, the first column is minus 3, 0, 0, 6, that we already seen. Second column is 0, minus 1, 4, minus 1. You can see 0, minus 1, 4, minus 1. The third column is minus 2, 0, minus 1, 0. This is minus 2, 0, minus 1, 0. And the fourth column is 0, 4, 3, 2. 0, 4, 3, 2. So this is the required matrix for L. We call it A, B, C, that is equal to this matrix. Okay. So this question was complete here. Next question, question 6b. Find the formula for T of x1, x2 and use into find T of 5 minus 3 for the basis S is equal to V1, V2 for R2, where V1 is equal to 1 minus 1, 1, V2 is equal to 1, 0. Let T from R2 to R2 be a linear transformation such that T of V1 is equal to 1 minus 2 and T of V2 is equal to minus 4, 1. So here we want to find the transformation T of x1, x2, right? and also using that t of x1 x2 we can also find t of 5 minus 3. We have basis vector for the domain. What is our domain? R2. Co-domain is also R2, but definitely we have a basis vector for the domain which are v1 and v2. That means what? Any vector of x2, any vector of R2 can be expressed as linear combination of this two basis vector, right? And using that that property of basis we can find the coefficient elements a and b. So, and also we have t of v1 and t of v2. So that means t of 1 1, that is 1 minus 2, and t of 1 0, that is minus 4 1. Suppose x1 x2 is equal to a 1 1 plus b into 1 0. Why we can write down this step? Because of 1 1 and 1 0 are basis vector for R2. So that means what? Any vector of R2 can be expressed as linear combination of this two basis vector. So that's why we can write down this step. Now x1 x2, that is equal to a plus b, a. So a is equal to x2 and a plus b is equal to x1. Okay, so put a is equal to x2 in this equation, so we get b is equal to x1 minus x2. Okay, and that's why we have b is equal to x1 minus x2, a is equal to x2. Put in this equation x1 x2, that is equal to x2 into 1 1, x1 x2, that is equal to x2 into 1 1 plus x1 minus x2 into 1 0. Now apply t on both the side. So we get t of x1 x2, that is equal to x2. Because of t is a linear operator, so basically right hand side we get t of x2 of 1 1 plus x1 minus x2 of 1 0, but t is a linear operator, so that's why x2 into t of 1 1 plus x1 minus x2 into t of 1 0. Okay, x2 into 1 minus 2, t of 1 1. What is the value of t of 1 1? You can see this is t of 1 1, that is 1 minus 2. Okay, and t of 1 0, that is minus 4 1. So x2 minus 4 x1 plus 4 x2, we get x2 into 1 x2 plus minus 4 x1 minus 4 x2. So finally you will get minus 4 x1 plus 5 x2. Okay, x2 plus 4 x2, that is 5 x2. Then minus 2 x2, second coordinate is minus 2 x2 plus x1 minus x2. So you will get minus 2 x2 minus x2, you will get minus 3 x2 and then minus 4 x1 plus x1, so x1 minus 3 x2. Okay, and so this is our matrix. If you want to write down this t of x1 x2 in form of a matrix, you can write down minus 4 5 1 minus 3 into x1 x2. Now also we want to find t of 5 minus 3, so put 5 and minus 3 in this equation. Minus 20 minus 15, so minus 35, and then 1, put 5 minus 3 in this second coordinate, you will get 5 plus 9 14. Okay, so t of 5 minus 3, that is equal to minus 35 and 14. This question was complete. Next question, question 6c. If t from R3 to R3 is a linear transformation given by t of xyz, that is equal to x plus y minus z, x plus x minus 2y plus z, minus 2x minus 2y plus 2z, find the basis of kernel of T and range of T. This question was asked in 5 marks. Now first of all, try to understand what is the meaning of kernel of T and range of T. Okay, first of all, kernel of T. Kernel of T, if our transformation T is a linear transformation, so in that case we can find kernel of T. How we find what is the meaning of kernel of T? We have to find out such elements from the domain such that image of that elements that is equal to the 0 vector of the codomain, right? So if our transformation in general, if our transformation T is from capital U to capital V, where definitely capital U and this V both are vector space, if you want to find the kernel of transformation, then in that case we have to find what is the exact definition of kernel of T, that I will explain to you. That is, we have to find out such elements from the domain such that image of that element that is equal to the 0 vector of the V, right? So we have to find out the such element from the U such that image of that elements that is equal to 0 vector of V. So that elements, the set of that elements called kernel of T. Okay, so here we want to find kernel of T for particular this transformation, where T of x y z is equal to x plus y minus z, x minus 2y plus z, and then minus 2x plus minus 2y plus 2z. So we have to find, you can see domain and codomain both are same. So this is our operator R3 to R3, and we have to find such x y z from R3 such that the image of that elements become a 0 vector. So definitely what we have to do, we have to compare each and every coordinate that is equal to 0. You can see x plus y minus z is equal to 0, x minus 2y plus z is equal to 0, then minus 2x minus 2y plus 2z is equal to 0, and then we find x y z. So definitely for those x y z, the image of that vectors under this transformation we get the 0 vector. So to find x y z, now we can use augmented matrix, right, because we have 3 variables and 3 equations, so it's quite easy to solve using this augmented matrix method. So the first row is coefficient of the first x y z from the first equation 1 1